Hello and welcome to the Genetics Podcast. I'm your host, Patrick Short. My background is in population genomics and studying the genetic causes of rare disease. I did my PhD at the Sanger Institute in the University of Cambridge and have been in biotech since 2018 when I started Sonogenetics. Sonogenetics helps academic and industry researchers to run large-scale genetic testing programs that speed up their clinical trials, generate data sets for the next big breakthrough, and give participants the best possible experience taking part in research. Each episode of the Genetics Podcast, we bring you insights from the leading minds in genetics and precision medicine, including household names and Nobel Prize winners, as well as early career scientists and biotechs working on the next big breakthrough. Whether you are a scientist, entrepreneur, executive, patient advocate, or simply someone curious about how genetics shapes our world, you're in the right place. Thank you for listening, and let's get started. Welcome to the Genetics Podcast, everyone. I'm very excited to be here today with Wanda Smith, who's the founder of CureGRN and is an amazing advocate for families affected by the progranulin-related neurodegenerative disease. We're going to talk about frontotemporal dementia today. We're also going to talk about her story, how she got so deeply embedded within this community, and also what the opportunities are now and going into the future. Just before I jump in, Wanda has had an impact across a range of different organizations, the FTD, Alzheimer's San Diego, the Milken Institute. She, according to a number of people, has just been instrumental to all the progress that's been made in GRN over the last couple decades. And I think it's going to be even more instrumental going forward now that we have 12, 13, maybe more different therapies that are in development and a lot of promise for families like yours. So Wanda, thank you so much for joining us.
Oh, thank you, Patrick. I appreciate the opportunity to talk about progranulin. And, I'll start by saying Happy World FTD Awareness Week. This week is the Awareness Week. So thanks for having me on. I appreciate it.
That's right. It's perfect time for this conversation. We're going to touch on the importance of awareness and diagnosis and making sure that anyone who is affected by this personally or has a family member who gets the chance to hear about your work and join. But I want to go back to the beginning. I think kind of got involved in this in the 1980s when, unfortunately, as a young mother yourself, you were put in the position of starting to care for your mother, who you didn't know at the time had FTD, but you later found out. I wonder if you could take everyone to that time in the 1980s and just give people a perspective of what you were working with then and how you got into this field.
Thank you. Yeah, I was 28 at the time. My mom was 52, and we started to notice changes, and she was working full time. And so we took her to a neurologist, and he yawned and checked her eyes, nose, and ears and said, it's Alzheimer's. Have a nice life. We're like, what? So we took her to a second one and then a third one who said, there really isn't anything in the 1980s to really help you. And I'm really sorry, but it is Alzheimer's. So that was 6 years of caregiving. During the time, there really wasn't much attention given to Alzheimer's. So in 1986, Life magazine they came in and lived with us for about 2 weeks.
Oh, wow.
They did a feature story on what it's like to have a young family experience Alzheimer's. And so the funniest thing, Patrick, was they took all these photographs, they wrote the article, and they sent me a preview copy. So this box comes in the mail, and I open the box, and it's the swimsuit edition of Life magazine. And I'm like, huh? And open the centerfold of the swimsuit edition is me 8.5 months pregnant. So I thought, marketing, they really wanted to get the word out about Alzheimer's.
Yes, I was going to say, that's probably one of the editions that you get the most moves through the shelves, right? So you got to really spread the word.
Yeah, so I think it put a pin in what the word was and started the journey of people thinking about Alzheimer's in a different way, and even young families thinking about it. So fast forward in 1987, a year after the article, my mom passed away. We had started with Dr. Bob Katzman here at UCSD, a brain bank, and he had freezers and we'd done fundraising. So when my mom passed away, it was natural for us to do an autopsy. Well, the autopsy came back, no plaques, no tangles. We're like, whoa, what is that all about? So Dr. Katzman, who'd written the paper on Alzheimer's in the 70s, He said, "Are there others?" And I said, "I have no idea." But I kind of consider the first phase of my life as finding people, anybody that was different than what the typical Alzheimer patient looked like.
Right.
So finding people was kind of the theme of my life. And for 18 years, we did just that. I worked closely with, I kind of look at my life as a partnership with scientists. And I think the consumer and the scientists together make a pretty powerful team. But we identified, I think we have over 450 samples of plasma. We have over 50 brains, and that 18-year journey of collecting specimens then led to the discovery of progranulin in 2006.
Yeah, was it at that time that you found out that that was what affected your mother? And then what happened after that?
Yeah, it was in 2006. So the Canadian group, Ian McKenzie and Dr. Feldman, basically found these cat eyes, they described it, and then they looped in the Mayo team, the genetic team of Mike Hutton and Rosa Rademacher and Mike Baker and what was her name? Oh, Jennifer Cass. They found progranulin, and within 2 weeks, I think it was, and then Dr. Allison Goat discovered our actual mutation.
Wow. And at that point, how much had you thought about frontotemporal dementia, genetics? Were there hints in the family tree, for example, that this might be genetic? And maybe you could talk a little bit about how I imagine your mission probably shifted a little bit then from going after these kind of peculiar cases of Alzheimer's, right? Or what it was thought to be Alzheimer's at the time, but didn't have the tangles or the plaques that you expected, to now actually you have a name, you have a molecular cause, but it changes your identity in some ways, right? Maybe you could talk a little bit about how you shifted your focus at that time once you learned exactly what was going on.
Yeah, focus did shift. I mean, anytime you do your pedigree and you start to see the black boxes that show that there's something psychiatric or there's something diabetic or there's something neurological, you start to get a really big hint pretty soon if there's more than one, something's going on. So what we did at the point that we discovered it was progranulin is, now what? And I had been told that it takes 30 to 40, 50 years to move from the time of discovery to a solution. Well, that was unacceptable.
Yeah.
So it was a matter of working with groups. We're NIH funded a lot, the AFTD funded a lot, the Bluefield Project funded a lot, and they really accelerated, what is this protein? How does it behave? What is it doing? And how's it affecting people? And people were just incredibly generous to step up and continue the samples and to continue to be tested and prodded and poked.
I want to just talk about my understanding of how GRN works in the context of FTD, and you let me know if I'm missing anywhere, and then we can kind of try to understand from here where therapies might come from. But my understanding is that it's a haploinsufficient gene, so they lose one copy of the gene, and having just one healthy copy isn't enough to produce the amount of the GRN protein that's needed. This leads to a reduction in the levels of progranulin in the blood, in the brain, and the cerebrospinal fluid. And this results in basically a buildup of toxic proteins because the lysosomal function that should be clearing out these proteins isn't where it needs to be. And then over time, this toxic buildup causes, frontotemporal dementia. Have I got that roughly right? Or are there any aspects of the cell biology story that I'm missing?
No, I think you've hit the nail on the head. People are born with two copies. With progranulin, you get one healthy copy and then you get a mutated copy. And the biology of the pharmaceutical products, which we have 6 in clinical trials now, they're all coming at it from different areas. So as the protein changes with age, and in my family, it happens from age 40 to 80.
Mm.
So the span of time is pretty long. They discovered that this second protein, I think there's a lot of associate proteins with progranulin, So sortilin is one that binds to progranulin and it goes into the cellular structure. And it's kind of like the garbage can. It kind of takes the trash out.
Yeah.
So they figured out in some of these products that if they can suppress sortilin, it will keep progranulin healthier, longer, and sustainable within the cells. And, my question to many of the pharma was, okay, so too little of progranulin generates FTD. Too much of progranulin generates all these unusual kinds of cancers.
Hmm.
How do you know that families won't get cancers? And they're like, no, we can incrementally measure this. And so that's been a really cool thing to kind of see how they understand pretty clearly how to control these mechanisms. Now, the other thing that's kind of interesting is a friend of mine, Jackie Shapiro, and you can go to our CureGRN website, our YouTube channel, and hear her story. But her mom was in her 50s and they couldn't figure it out. So I'm finding the more aggressive the family is, the more they get to genetics quicker.
Yeah.
And so they found that her mom in her 50s was progranulin. And they're like, wait, this makes no sense. The grandparents are in their 80, 85, and they're healthy. There's no sign of any disability. So Jackie and a bunch of the scientists went to work and found that it was TIM106B. So now we know that in progranulin families, there is a small group that may have a protector gene.
Wow.
So the more they peel back the onion, they discover so many pieces of progranulin. And now there's some real good science that progranulin may be a driver in Alzheimer's, Parkinson's, and now Lewy bodies. So I kind of think it's king. What can I say?
Wow. So in all those other conditions, is it that if you lose the whole copy, you're more likely to end up down the FTD path, but Alzheimer's, Parkinson's, Lewy body, it's an incremental risk factor, for example, where it might just be a change in expression of the gene, or maybe people that have one of these modifier variants, like the one that you mentioned. Is that the emerging story?
I don't know the detail of the emerging story, but I do know that they see that a deficiency in the level of progranulin may be an indicator in other diseases. And what that level of deficiency is, I don't think they've actually figured out. They're just seeing it across the neurodegenerative spectrum. So I have real hopes that these clinical trials, I mean, we've got small molecule clinical trial pharmaceutical companies, we've got large molecule. We've got 2, 3 in the AAV specter, which is kind of an implantation of the progranulin directly into the brain, either in the back cavity of the brain or in the thalamus directly. So, and those are all, I think the first one reads out the fourth quarter of this year. So that will be the first one that actually gives us something to hang our hat on. But I want them all to be successful, whether it's the infusion method or pill method or what we call the one and dones.
Yes. Yeah, or the gene transplant. I hear some people talk about gene therapies that way, and it's a nice analogy, right? Because you can go in, like you said, and deliver a additional copy of the gene to the specific cells or the brain, and hopefully have an effect that completely restores function of the gene or comes close to it, right?
Yeah. And, I think it proves a couple of things. Families are willing to take risk, high risk. I think it also is beginning to show us that we need these interventions earlier. So we've got to lean into some of the other ecosystems of how we get a diagnosis, how soon can we get a diagnosis, and kind of a bigger role that genetics and genetic counseling and genetic testing has got to play in family health. This kind of the current sequence is that, oh, you have all this other stuff done. And then, oh, maybe if you can convince somebody to get a genetic test, then that kind of comes at the end. But I think we need to flip the script and get that genetic piece in much sooner. Like, for instance, with progranulin, many of our families that are in CureGRN have told me they went to the doctor took three neurologists. It took over 3 years. And the thing is, their MRIs showed their brains being normal. Yet the behaviors, the language, the motor challenges were all there. A simple spit test could have taken, blood test or spit test, either one could have made a huge difference in the journey that family had, the pain and agony of not knowing.
Yeah.
It just doesn't make sense that in our day and age, with so much being discovered in the lab, that we don't know.
When you talk to, health authorities or insurers or pharmaceutical companies, what do you hear about why this diagnostic odyssey and lack of genetic testing happens? Is there something structural that's in the way, or is it more there isn't somebody to pay for it right now? It's slow. What is it that you hear from people in the industry?
All of the above. I mean, it's a real challenge to get the doctor to write the order, even when the family says, I'll pay the $760, or there's some free opportunities that pharma have, stepped in to say, we're going to help families with this. Even to get the doctor to write the order is a real challenge. And, most of them I think are well-meaning. I think there is a cultural thing, that concern that they may not know that there's opportunities for treatments that are this close to being out there. I know I spoke at the hub meeting last year. I'm part of a group called Cures Collective, which I think is going to be a game changer. It's about 50, 60 neurological conditions altogether. And we spoke at the neurological conference, and I didn't see anything on genetics.
Yeah.
So I think changing that will help, just getting a neurologist to feel comfortable that there are opportunities.
Yeah, I often think of it as a sort of a catch-22, where if the neurologists aren't comfortable with it, for example, then genetic testing doesn't happen. And that makes it that much harder to run clinical trials, to generate the evidence, to get these gene therapies or small molecules to the evidence base, where then people start to test. So you have this challenge where we have to figure out a way to accelerate diagnosis, because then that will fill the evidence gap, hopefully by giving more people the opportunity to not just take part in trials. But my guess is that there's also probably a very big evidence gap in how patients or families with GRN progress differently from certainly the Alzheimer's community at large, but even within FTD, right? Is it earlier presentation? Is it more severe or less severe? And what are the biomarkers that might indicate whether someone is going to become symptomatic, and at what time, right? Because we all want earlier trials that prevent rather than treat. But if you're years or decades behind on this diagnostic odyssey and you don't get that genetic diagnosis until the symptoms are so obvious that that it becomes too late, then you really can't run these prevention trials, right?
Yeah, and it takes such a long time, but the more aggressive families really get on it. And I think the change is actually going to be our younger generation, because I'm seeing 30 and 40-year-olds now that are getting tested no matter what. They're gonna solve this problem, and they're going to be engaged. And as far as, I think we've got to move away from this theology of symptoms, of diagnosing by symptoms. Because when you're looking at symptoms, you're all over the place. When you get into the biology, so moving from symptoms to biology makes a lot of sense. And if we can kind of get everyone to wrap their brains around, we got to get to the biology. And the biomarkers are the way to go, because we now have neurofilament light, the NFL. I said, is that the football league? They're like, no, that's not football. But, we have people who are really eagerly checking their NFL numbers. And that seems to be an inflammation marker that will give, families and younger individuals some hope that they can look at this disease in a totally different way. How do we be preventive and not wait for the causal of a massive disease, which once the cascade starts, it's very hard to stop.
Yeah. Maybe you could talk a little bit about your international efforts because you've done a lot of work in the US, but I think the CureGRN community is expanding well beyond the borders of the US. How important is it to cast a very wide net internationally to make sure families in every corner of the globe have access to these kinds of resources? Is that a big priority for you all?
It is a really big priority. And, one of the most impressive groups is GenFi, which is out of the EU, UK. And so we're having discussions with them. How do we find more progranulin? There's a group that already has a lot of progranulin people, so trying to connect everybody. We've had discussions with India. India is one of the largest populations, and five of the centers there are beginning to discover progranulin family members. So, we're a very young organization. So looking at fundraising, getting more scientists involved and trying to help us get the word out. So we've actually started a thing where we encourage scientists to take our Instagram or our LinkedIn and just repost it. So maybe
Yeah.
we can get a little bit more visibility, but yeah, because everyone's got a LinkedIn account. Maybe not me, but everyone else.
Yeah, when it comes to getting scientists interested, what do you think is the biggest gap right now? And where, is it at the very early basic research of understanding how the protein works? Is it about therapeutics? Is it about understanding, some of these more healthcare system level issues, like how do we encourage access to genetic testing? It's probably all of the above, but if we think about where the biggest impact could come from today, what's your sense of where the biggest gap is?
I think in the ecosystem is just awareness across the platform. I think Emma Willis has done a beautiful job of bringing FTD to everyone. I mean, it doesn't take much of a conversation for people to say, oh, yeah, that's Bruce Willis. So I
Yeah.
think putting a pen in it and bringing that level of attention, I think the recruitment, there is so much fear, there's so much apprehension among people getting involved in these trials. And I think we can all do a better job of explaining it, rallying behind the efforts. I mean, these are not expensive endeavors. And my goodness, out of six of them, if any one of them gets a little bit of a hit, it levels and increases the entire neurodegenerative space.
Yeah.
So,
What do you think the big source of fear or uncertainty is from potential trial participants? What do you hear most in your community groups?
I think shame is a big piece of it. I think being labeled,
Yeah.
we come out of a culture. It's kind of unfortunate, but we're using nomenclature that's over 100 years old. Even the word dementia means insanity. So you just apply that to these kind of horrible stories that, oh, well, a person with dementia can't do XYZ. And so kind of changing that these are healthy individuals. In fact, I'm surprised most of the progranulin folks on our team are high professional, college educated, PhD educated individuals. So I think that fear and the shame, we can do a much better job. And there again, Emma Willis is putting a face on it as to the disease itself. And really, we can be bold. I told her, I said, you have given even people like me a courage to be bolder and step out.
Yeah, that's amazing. Do you think more of those public personas just help to destigmatize and lower the barrier?
Yeah.
Yeah.
It makes a difference. We have many in our CureGRN. Some will talk about and are willing to be videoed and public, and others aren't because they're concerned about loss of job, loss of income, loss of insurance,
Yeah.
the loss of long-term care. So I think fixing some of those areas and giving people a sense of comfort that genetics is not a bad thing. We're born with it. We just don't know it.
Yeah.
So what's the problem in knowing your health? I mean, that's a good thing.
How big of a challenge is having these conversations within families? Because sometimes you'll get brothers, sisters, cousins, or mother-father relationships where it's just the last thing that people want to talk about because of the trauma or the shame or some other reason. Is that a pretty big topic of conversation as well?
It's a big topic.
Yeah.
It's a barrier, to be honest with you. So you have like the type A's in the family who just they jump in, they're like a fire hose. They want to learn everything. They
Yeah.
can genetics and FTD and progranulin. And then you have the others who are like, oh, hey, don't talk to me about that. And so you have to balance it. I call it the breadcrumb approach, is that you have to take people where they are and you have to slowly feed them the breadcrumbs. Now, even the ones who, you know, I can kind of turn it on a bit too thick. So even me, I have to dial it back and rewind and think about, okay, what is it they want? Let me try to deliver where they want and what they can need and absorb at this point. But I'm always there for the future. And I think the beauty of CureGRN and the amazing team that we have built in such a short amount of time is that we're trying to provide information, education, and science at their fingertips. They don't have to go all over the internet and do the Google doctor. They can come to CureGRN and hopefully we can deliver things in a way that they can then encourage family members that they can, sorry, I get a little upset, I get a little passionate about this, but that we can be a facilitator of education and information that brings those breadcrumbs right to their front door.
Yeah, I think it's great. And looking at your website, you've done a really good job at providing lots of different mediums for people because there's some people, like you say, that want to jump right in and be part of a WhatsApp group or a Zoom regular meetup. But you have other people, that's the last thing they want. They just want to read about it and they want to digest on their own time. And also making it accessible to people, regardless of whether they have a great healthcare provider that they have a good relationship with, because some people are very fortunate where they have that neurologist that has helped them get a diagnosis and is all over the science with them. But there are also many people who just don't have that, right? And they're on their own a little bit until they find their way to that specialist that can help them, right? So you have to really think about all of those different routes in and not have a one size fits all approach, right?
Yeah, it makes a difference. I mean, my background is marketing, so I think about it in a different way that you have to deliver the message 7 times in 7
Yeah.
different ways to try to get through the clutter that's out there in the, in our universe. But I think having scientists, having researchers who get involved and really join in and let their families know, hey, we don't have a cure yet. We're really on the horizon of getting a cure, though, within a really short amount of time. But hey, in the meantime, let's connect you. And then what we do at CureGRN is we really spend a lot of time. The AFTD has a wonderful helpline. They have great genetic support groups. And so getting them attracted to us and then encouraging them to link in and to connect and engage with the AFTD is very important as well. So it's kind of linking people from the field to kind of the resources that are going to carry them to a positive place in their life.
If we look at what the next 5 or 10 years may hold, let's assume that one of these 6 or 7 programs that are in clinical trials right now, or one of the 6 or 7 that are in early development and haven't quite transitioned to trials yet. If one of those is successful, what does the future look like, and what becomes the most important thing after that? If we're able to treat, some group of patients, what do you want to see happen after that?
Oh, game on. I mean, if we can actually get this disease slowed, slow it down, begin to look at how do we put the brakes on it, then I think we have to change our funding, our insurance system. We have to change our delivery of care. We have to turn genetics to be kind of the front part of the care continuum instead of the back end of it. But I think it changes a lot. And I think it changes actually science because we've spent so much time on amyloid and we've invested so much money on amyloid and the Alzheimer's diagnosis that it will start to raise the awareness that, hey, all these other diseases that fall into the TDP-43 spectrum, maybe they're not so rare after all. Maybe that's a bigger pool of people. We just haven't actually identified them. So I'm hoping, and it certainly is the third theme of my life, is how do we get from, these small discoveries, the small increment of success, to getting everyone to know what they have.
Yeah. When it comes to genetic diagnostics, for example, are there countries or states or places that you think are really forward-looking on this that maybe the rest of the world can learn from? Or is everyone struggling?
I think we've got a lot of work to do in that area. In fact, some of the countries, they don't even agree with it. So we really do have a lot of work to do, state by state and country by country. But I honestly think the dominoes will fall if we can put a strategy together and work together.
Yeah. I mean, with that in mind, people can go to curegrn.org. And if they want to help with this, I think you've got a way to donate. That's right in the top right corner. And also, like you said at the beginning, if people are, they themselves or have family members that might be affected by this, then you make it really easy to join, learn how it might impact you, and just get started. I love your message about trying to get to people in 7 different ways across 7 different mediums, because sometimes it doesn't stick the first time, right? You hear about this and you think maybe it's not for you right now, or you're not actually sure. You have that family member that has unexplained dementia, and you're not sure what the right next step to take. So it can't hurt to get online, get a little bit curious, and join a community if it makes sense to help you or help your family members.
Yeah, and it may not be progranulin, it may be MAPT, it could be VCP, and there are organizations for those genes. The AFTD has a great resource site for genetics. So families, even if they're listening to this and they're not progranulin, they can go to the AFTD website, the genetics section, and learn a lot more about all of the genes involved. I think the genes are going to make, I understand sporadic, but I was told by Dr. Michael Ward that it's possible that at the end of the day, the sporadics may be genetics. We just don't know it yet.
Yeah, it seems to be the case in a lot of diseases. That I think that my current research on GRN is that it's about 5% of sporadic cases, maybe up to 10%, that have the monogenic form, and it may be 20 to 25% of cases with a known family history. But that doesn't take into account polygenic background, other, complex genetics that over time may actually account for far more of the sporadic cases. It's hard to know until we have the comprehensive research and big data sets and really look for it, right? So I think we should think of this as an absolute minimum today, but almost certainly it's going to go higher over time.
Yeah, and I look at it as a minimum, no question about it, because there haven't been large epidemiological studies to really pin this. And if you have the majority of your population isn't getting genetic tested, how could you know?
Yeah, that's right. One thing I wanted to ask you about actually is people who are, younger family members who may be years or decades out from ever expecting symptoms, and to your point, they may never come, right? How do you think about that group? I think your curegrn.org has resources available for them, but it's a really different population, right? How do you think about it? Is it open to people regardless of whether they have symptoms or not? And how do you think about that journey?
Yes, it's open to everyone. And the journey is different. I mean, they're looking at family planning issues. They're looking at, 10 to 20 years of this disease. When will it strike? When will it not? So I consider that whole group, they're inspiring me every single day. They're loud. They want this done. They're actually very engaged individuals. And they're just not going to they're not going to listen to people when they say no. The barriers, they're going to knock them down one by one. So I see the younger individuals as being really a loud voice in all of this discussion. And you'll see a lot more visibility in the younger population than the older population, which I think is wonderful. Their message is stronger. They've got I mean, some of our folks have like infants, 3-year-old, and they're trying to juggle this disease of caring for a parent. Now they've got the young one, and now they know that they are positive. It's a really heavy journey for people, but I think they're in it to win it.
Yeah, I absolutely agree. We've had a number of guests over the years on this podcast talking about the journey of gene carriers in ALS. And we didn't spend too much time on this today, but obviously FTD and ALS share the C9orf72 gene as a common genetic cause. But to the point you made earlier, these are part of the larger TDP43 family, and there are almost certainly links between what we're talking about today and ALS in fundamental ways that we haven't fully understood yet. But even looking beyond the genetics, we have a growing group of neurodegenerative neurological conditions where you've got, because of the rise of genetic testing, many, many more people who know their status years or decades in advance. And I just think it's really important for us as a field to wrap our head around how we do early disease detection and prevention and push these clinical trials, obviously safely and responsibly, but earlier through the use of, whether it's blood-based progranulin levels or NFL neurofilament light, like you mentioned earlier, ways to couple the genetics with some other more continuous readout of are we actually getting close to symptoms or starting to see symptoms come on? Because I think the earlier that we can treat safely, the better in all of these cases, right?
Yeah, and absolutely. I think the earlier we treat them, and we need to kind of look at this ecosystem that we have this population, they're there, they're going to be loud. So how do we look at care management for them over 20 years before disease onset? We're being told now, well, no doctor's going to check me. Oh, so research can't be the only option for young adults who actually know their genetic status. So how do we put kind of a care plan or care management to keep them in research, but also to really monitor their health for the future?
Yeah, that's right. Well, Wanda, thank you so much, not just for joining us today, but for all the work that you've done over decades for this community. Thank you on behalf of everybody now and in the future who will be affected and hopefully someday cured by all the work that's being done in this field, thanks to you and many others.
Thank you, Patrick. It's so delight to be on with you, and thanks for making it so easy to share something so important to me and to many others.
Absolutely. And perfect timing with the awareness week that we're announcing this episode, releasing this episode in conjunction with. So thank you, Wanda. And as always, thank you everyone for joining us, and we'll see you next time. Thanks as always for tuning into the Genetics Podcast. If you enjoyed today's conversation, the best way you can support the show is by sharing it with a friend or colleague who might find it interesting as well. We'd also really appreciate if you could subscribe, rate, and review us on Apple Podcasts, Spotify, or wherever you listen to podcasts. This helps other people discover the show when they're searching for content on genetics, precision medicine, or biotech. We always want to hear from you as well. If you have feedback or questions or want to be featured on the show, you can email us at podcast@sonogenetics.com. You can find me on LinkedIn, Patrick Short. You can find us as well, Sonogenetics, on LinkedIn, or reach out on Instagram at The Genetics Podcast. And finally, a special thank you to the team behind the show who makes this possible. Joy Ismail produces and manages the show. Jane Reddy-Webster keeps us organized, and James Pierce from Selective Frequencies for his expert audio engineering. I'm Patrick Short, your host. Thanks again for listening, and we'll see you next time on the Genetics Podcast.